Go.
All right, so now we're going to talk about how we put these things together. Now, quantity statements are essentially special, really you can think of conditionals are special cases of quantity statements. Conditionals are quantity statements where the quantities are all none and all, right? So for instance, no A's or B's is essentially saying if you're an A, then you're not a B. But you could also say that is all A's are not B's, right? So quantity statements always involve two groups. And those you can't have a quantity statement without two groups. If I say all A's, what does that mean? Nothing without, giving you a second group. If I say, all the people in here got A's, that means if you're in here, then you got an A, or if in here, everybody in here, all two got an A, right? So you can always put it as a relationship between two groups and then a quantity that connects them, right? So for instance, let's look at this one, number 1, right? Most serious students are happy students. That first statement. What's the relationship there? First of all, what's the two groups? That's what you always want to establish first. The two groups your quantity is related.
Serious and happy.
Yes, serious students and happy students, right? Now what quantity connects them? Most, right? Because most has a definite meaning. It definitely means more than half, right? Now, so also does most have a directionality? That is most serious students happy the same as most happy or serious? No, right? So which way is it going?
Happy.
Yeah, from most of these are that, so the directionality is that way. All right, everybody follow that? So then what's our next statement then, Jill?
Most serious students go to graduate school.
All right, but we have one group we've already talked about. Yeah, we got serious. So we have a new group here, graduate students. What's the quantity relationship here, Jill?
Again, most with a direction.
All right. And then what is our final statement then, Josh?
Furthermore, all students who go to graduate school are overworked.
All right, and do we have a new group here?
Yes.
Overworked,
Those
right?
are overworked.
All right, we've already got graduate students, and what's your relationship here?
All who go to graduate school are overworked. So,
It's an all
Going to the
going
right.
from what to what?
all from left to right.
Yeah, all from graduate to overworked, right? So that's how we graph that out. Now let's talk about the rules we use to apply this. The good news is that there's really only 4 rules. One isn't even actually a rule, it's how you can transform things to get it into a good form to use, right? The first is how we do none, right? No A's or B's kind of is a sucky thing. So we don't want to do that. What we want to do is change that into all A's are not B, right? Everybody get what I'm saying there? That's the same as no A's or B's. It's the same as saying all A's are not B, right? Now we also can do the contrapositive of that, and you'll need to know this because sometimes the answer is not phrased like this. It's phrased in the contrapositive terms, which are that all B's are not A, right? And how you graph that out will kind of depend on, do you have other things that talk about not B or not A, right? Or they talk about A or B. If you have if your next statement is about A, you want this version. If your next statement is about not A, you want that version, right? You want whatever's easiest to connect up to, right? All right, so that's your first thing, and that's about how to turn no and none and nevers into alls. Because if you have no, none, and never, you get way too many rules. There's like 16 rules if you have to take no, none, and never into account, whereas there's only 3 if you don't, right? Your first real rule is going to be what we call positive quantity reversal. And it sounds complicated, but it's actually super stupid and simple, but it's worth, saying. Any positive quantity going from one thing to another, so that's going to be all, or some, or most. Any positive quantity going from one direction to the other tells you that some goes the opposite way. Right? If we know that all A's are B's, do we know some B's are A's? Yeah, whichever one were A's, right? If we know that some A's are B's, do we know some B's are A's? Yeah, whichever ones were. If we know that our most A's are B's, we know some B's are A's, right? Now, all doesn't tell you all going the opposite way. All doesn't tell you most. Most doesn't tell you most. Any one of these going one way tells you some can go back the opposite way, right? Everybody follow that?
And some could mean all, but it doesn't have to.
Yeah, again, when we write things up there, we're writing down what we know for certain, right? All right, your second rule is what we call the multiple most rule. All right? And that's if you have one group and multiple mosts or all, because obviously all means most, right? Going to two separate groups, then we know some connects the two groups. All right, everybody get that? Because you can't take more than half out twice, right? So if you got a most or all coming out more than once, then you know that some connects the two things coming out of it. And it's important that those most are coming out of that thing. The idea being you can't take more than half out twice without there being some overlap. All right? And our third rule is what we call the all highway. These names get progressively cornier, I guess. Right? Start off all technical sounding for the easiest one, and then start off all corny for probably the most technical. And that's if you have one group connected to another group, and then that group connected to a third group with an all. Whatever this quantity is connecting the A and the B, whichever one that is, then connects A and C. Essentially, if you've got this all coming out, everything that comes into that gets to jump to the third thing in the chain, right? So if it was some A's or B's and all B's or C's, we'd know some A's or C's. If it was most A's or B's and all B's or C's, we'd know most A's or C's. If it was all A's or B's and all B's or C's, we'd know all A's or C's, right? So some, most, or all. And the directionality of the arrow is highly, highly important there. Like, for instance, if this was an all and that was a sum, we couldn't apply it, right? It only applies, you take basically whatever the all's coming out of, whatever goes into that jumps to whatever the all's pointing to, right? And those are the only three rules you need when it comes to quantity statements, right? Which is actually really nice, and it's much less complicated than any other way. So let's apply some of these to what we have going on here, right? So who can apply some of these?
The last one you just did.
All right, so what does that tell us, Jill?
It tells us that, let's see, most serious students are overworked.
Exactly, right? So we know that. All right, because since this most goes to there and then it all comes out, that most gets to jump, right? Dave?
No, I was just waiting for the next one you asked.
Yeah, go ahead.
Because of the second rule, we know that some HS are GS and vice versa.
Yeah, exactly. We know some connects those two because we've taken most out of SS twice, right? Everybody good there? So Jill, can we use the rule you just used the first time on this new thing?
On that new thing.
So we just figured this out.
Yes. Then, I feel like I'm being trapped, but I would say that you can then say that some happy students are overworked.
And what you would say would be correct. All right? Because since the sum connects here and then that all comes out of that, everything that goes into GS gets to jump to what the all is pointing to overworked, right? All right, so let's look at our answer choices here. This is an inference question, right, number one. Normally we wouldn't necessarily do it this way, but this one, more what we're using for than anything else is to talk about, it's good because we get to use all of our rules, right? So let's look at A. Most overworked students are happy students. All right, do we know that? No, we know some, but we don't know most, right? What about B? Some happy students are overworked. Do we know that? Yeah, that's what Jill just told us, right? C, do we know all overworked students are serious students? Yeah, we definitely don't know that an all goes that way. If it had said some, that would be an answer, but not all. right?